Welcome back, marvelous M3 students. We are on to our next lesson. We are going to be looking at the interior angles of polygons. Now, before we get into the lesson, let's review what a polygon is. A polygon, poly means many, and gon means sides. So polygon, the word polygon means many sides. And there are three things, three properties. It must be closed in order to be a polygon. So this right here is not a polygon. It's not closed. I haven't attached all of the sides here. But if I do this, that is closed. So that is a polygon. So not polygon is a polygon. No intersecting sides. So not a polygon because these sides intersect. That one, whoops, that didn't close very well, did it? There, that one would be a polygon. So not a polygon is a polygon. And then finally, the third one, no curves. So this right here is not a polygon. A lot of students often tell me that that looks like toast. Okay, but this one is a polygon. There are no curves. Okay, everybody good on what a polygon is? Let's get on with the lesson. So hopefully you all remember that the sum of the angles in any triangle is 180 degrees. No matter what the shape of the triangle is, no matter what it looks like, how big, how small, all three angles have a sum of 180 degrees. So we're going to take that information and we're going to see what's going on with these different polygons. What we're going to do is divide each polygon into triangles by drawing diagonals from one vertex to all of the other vertices. So if I look here and I pick, let's say this vertex here, a diagonal is not a side. So I can't connect that. I can't connect that because those are sides. I can't draw any diagonals in the triangle. So if I move to the quadrilateral, I'm going to pick this one. It doesn't matter which vertex you choose. I can't choose this. I can't draw that, and I can't draw that. Those are sides. But I can draw, should go, oh my goodness, that's awful. It should go vertex to vertex. Let's fix that. All right, so there we go. In the quadrilateral, I can break it into two different triangles. So I'm going to do the same thing with the remaining ones. So pick a vertex, draw the diagonals that are not sides. And one more. Okay, so now we got this little table. Let's see what's going on here. It gives us a triangle. It has three sides, one triangle. So one triangle has 180 degrees, so total of 180. Quadrilateral has four sides. How many triangles were there? Two. So we're going to do 2 times 180 degrees. So that gives us a sum of the angle measures of 360 degrees. If I add up all the angle measures of this quadrilateral, I will get 360 degrees. And that's true for any quadrilateral. So squares, rectangles, trapezoids, they all have angle sums of, interior angle sums of 360 degrees. The pentagon has 5 sides. Number of triangles, 1, 2, 3. There's 3 triangles. So 3 times 180 is, oh my goodness, 540. Hopefully my math is right. Hexagon, 6 sides. How many triangles? 4 triangles. So we're going to do 4 times 180. 4 times 180 is 720 degrees. And then finally the heptagon. Heptagons have 7 sides. There's 1, 2, 3, 4, 5 triangles. So 5 times 180, and that is 900 degrees. How much does the sum of the angle measures increase from a 4 to a 5-sided polygon? So from a 4 to a 5-sided, so that's quadrilateral to pentagon, we went from 360 to 540. That's an increase of 180 degrees because we added one more triangle. How is the number of sides of the polygon related to the number of triangles that make up the polygon? So how are the number of sides related to the number of triangles? So if we look here, what do you notice? There's always 2 more sides than triangles. So if I did my sides minus 2, that equal, let's say number of sides, minus 2 equals number of triangles. Okay, that's interesting. Okay, on to the back. Write the formula for finding the sum of the angle measures of any polygon. Use S equals sum of the angle measures and N equals the number of sides. Okay, so we're going to have S equals, that's our sum, that's our total. So we're going to do a bunch of stuff to figure out that sum. So let's flip back to the front. These are all of our sums right here. Well, how did we get these sums? We did 180 degrees times 2. Well, what does the 2 represent? The 2 is the number of triangles, and that is true throughout. We did 180. Oh, I forgot all my degree signs. We did 180 times the number of triangles. Okay, so let's go back. So 180 times the number of triangles. Let's go back, and what does it say, though? Our formula is based on the number of sides, though. Well, how do I get the number of sides? How do I get the number of triangles if I know the number of sides? Well, let's go back. What did we say here? The number of triangles is the number of sides minus 2. The number of sides minus 2. The number of sides minus 2. I want to multiply this whole thing by the 180. I need to find the number of triangles before I multiply. So in order to do that, the n minus 2 must be in parentheses. So that is the formula to find the sum of the interior angles for any polygon. It will work no matter how big or how small, no matter how many sides the polygon has, this formula will work. So use your formula in number 5 to find the sum of the angle measures of a nonagon. Well, you got to know that vocabulary. A nonagon is 9 sides. So write your formula. First line of work every single time. Write that formula. S equals 180 times n minus 2. So we're trying to find S. 180. N is 9 minus 2. So S equals 180 times 7. Got to get that handy dandy calculator. 180 times 7 is 1,260 degrees. Use the formula in number 5 to find the measure of one interior angle of a regular octagon. What does regular mean? It means all side lengths are the same, all angle measures are the same. And then octagon, hopefully you know, is 8 sides. Okay, so S equals 180 times n minus 2. We're trying to find out what the sum is. We're going to find the sum first, just like we did in the last problem, but there's an extra step here. So 180, n was 8, so 8 minus 2. S equals 180 times 6. Again, that trusty calculator, 180 times 6, 1,080 degrees. Now that is not our final answer. That is the sum of all of the angles. We want to know one angle. Well, since it's regular, that means all of the angles are the same measure. So I can simply take the 1080 and divide it by the number of angles, which since it's 8 sides, there's 8 angles. So 1080 divided by 8, and that is 135 degrees. So each angle is 135 degrees. All right, last problem. We are almost done here. Use your formula to find the value of x. So this one is another one that requires 2 steps. The first thing we want to do is figure out what the sum of all of these should be. So s equals n minus 2 times 180. So s equals, this is a quadrilateral. There are 4 sides. So 4 minus 2 times 180. And then 2 times 180. And we get s equals 360 degrees. That's the sum of all of these. And we actually knew that. We talked about that on the front. Every single quadrilateral is 360 degrees. But it did tell us to use our formula, so we're just showing that, proving that. So now I need to know what x is. Well, I know all of these added up will equal 360. So, and it does say show work algebraically, so you need to show this. X plus 60 plus 125, and then hopefully we all remember that this symbol right here is your right angle symbol, so plus 90. We know that will equal 360. So let's simplify this side. X plus, let's see, 60 plus 125 plus 90 is 275. And then just a little wimpy one-step equation here. We're pros at that. So 360 minus 275, and we get that x is 85 degrees. Whoops, sorry you didn't see all that before, but there is the work. Again, as usual, if you have any questions, make sure you contact your teacher, and hope you've enjoyed it. See you soon.